Hello, everyone. Thanks for joining that session of the P7 user conference. It's now 10 past 11. And we have the pleasure to welcome Mr. Martin Potonnet from Liber Aerospace. So Martin is a modeling and tool engineer at Liber. And his presentation fits in the P7 Enterprise section of this conference. So Martin, thanks for your participation, and the floor is yours.
Thank you, Laurent, for the introduction. So, yep, let me start that presentation. So, as Laurent said, I'm working at Liber Aerospace in method and tools, and I will quickly introduce that presentation first. So, first we will see the big picture of the environment at LTS, so Liber Aerospace Toulouse. We'll see the ecosystem and the constraints that we have in that ecosystem, and see also how the web PIDO proposition fits to our need and these constraints. Then we will go into the details of the use case that I would like to share with you today. We will see the background, physical background, the need, and finally also the model and the data, the reference data that we will use for the calibration of this model. And finally, I will explain how we implemented that problem into an optimization problem, and how we implemented that into the workflow. And hopefully, I will have time for a live demo to see how things works for the end user inside P7 Enterprise. So just a quick introduction on our company. So we are Liber Aerospace Toulouse. We design, supply and service air management systems for all kind of aircraft, from commercial aircraft, helicopters, to fighter jets or business jets. Air management system is made of several subparts, which we call products, and you can see some of them here below. So inside the air management system we find air cycle machines, we find compressors, heat exchangers. We also design controller device, and control. We also design control loads. All these products are designed inside separate teams, but what is important is that we have a single method and tool teams to address the need of the different product teams. And more and more we use models and optimization to design and build more performant products. And it is very common that we encounter that kind of sketch which we see here. So we have a team and team members of product teams which want to design better products. Who have a model to calibrate or some processes to automate, and we also have a different team who has the skills to achieve these goals, to derive optimization problems, to automate the design, to do programming tasks. It doesn't have to be a separate team. It can be someone inside that, let's say, product team, who has the skills and would like to spread new methods and new models and new techniques inside for the non-experts inside the team. So in general, what happens, the general workflow is that the product team identify a need, formulate the need, and communicate with the expert. The expert collect that need, make a first analysis, and proposes a solution. And the non-expert team will use that solution, make some first feedbacks, maybe propose some improvements, and we have that iterative process here, which engages, and this becomes more and more obvious to us that we need a new method and new tools to ease that iterative process, which can only bring improvement and better better performance. So to summarize, we have mainly two actors. Let's say the optimization expert here, and the end user, who is not necessarily an expert, but has a need for more efficient techniques and more advanced techniques. We also have a third actor, who is the IT department, who provide hardware installation of different solutions and applications, and they also are responsible for data security and data access. So they are also here to apply security constraints, um, and we have to take that into account, of course. And also a third task that I would like to mention is that the installation and maintenance of the solution or the application is in general separated or shared between these two actors here, the method and tools and the IT. And also it's the same for the back and front development. Both teams have the ability to develop back-end and front-end solutions, and it's not always so clear who should be responsible for the development. Now let's switch to the WebPido proposition. We think that it is a great proposition to address all these needs and constraints. Here we have the IT, which should be responsible for the installation and and should provide the server and the hardware for the web application. And then all the end users and the optimization experts need to do is to push some codes to collaborate on the centralized object, which will be P7 workflow. So that's a great way to our knowledge to separate the roles between the IT department and the, let's say, business teams. So in a way, the end users use the platform for collaboration. For I mean, the experts will propose a solution and get some feedback from the business team. The business team can also configure and run the workflow, make some tests, make some feedback directly on the same object. And this is really um, a way to speed up the development of applications, of that kind of application. We also have the ability to publish some apps based on the workflow. This is not so advanced on our side, to be honest, but it is something where we see a lot of potential. Um, and something also we would like to test is the REST API for connection with external tools. So in terms of advancement, we have tested the collaborative part, the fact that we can edit some object, some centralized object, and check that that we are converging on the proper solution. And also we have published this workflow in read-only. We will see that, and we have checked that these workflows are very easy to configure and run for the end user. And if something is wrong, something is not working, it's very quick to make a feedback to the development team and tune, I mean, and debug the workflow, make some changes and improve. It's very fast. To have a good idea of the goal that the engineer is trying to do, and this can be summarized as such. We have actually several data series that we want to fit to some reference data series. So typically we have like tens of such a graph. The green line, the green data series, is the reference data series. The red one is the current result of the model, and the blue one is is the is the the result of K1, K2, which are being tested. So in the end, what we are willing to do is to fit the blue line on the green line. and we transform that into a scalar metric, which we call it relative root mean square, so RRMS, and we have one RRMS for each curve that we want to fit. I don't remember exactly, but I guess we have like 20 or 25 RRMS, and naturally we want to minimize the sum of all these errors. This is our objective. So we already see the optimization problem being derived. We also had some constraints. We would like the error for each profile to be less than a value. We do so because we don't want one objective to be perfectly calibrated and all the other being badly calibrated. We want an equilibrated calibration, so a balanced, let's say, calibration between all the profiles. So that's why we had some constraints, and this is possible because we use a real optimization object. We don't do simple least square problem or resolution solving. And then we must also agree with the system engineer regarding what value are okay to select for K1 and K2. So we must define with the system engineer what are the bounds, with the acceptable bounds for K1 and K2. So all of this needs to be agreed with the system engineer. So of course this comes from the optimization expert, but the system engineer needs to agree on the problem formulation so that it really addresses its need. That's really important, and this is where the workflow plays a significant role, because if the optimization problem were only implemented inside I don't know, some Python script or some MATLAB script, it's okay for someone who is expert in programming, but then for sharing the problem and explaining um, what is actually the formulation and the optimization problem that we are solving, it's very important to have some graphical interface to explain and to discuss. So what we have implemented is a classical optimization inside P7. We have this design space block here to define the bounds and the objective and constraints. We have the fit model, which um, captures the business rules, so how to compute the errors for each profile. Also inside you have the formula to compute the flow rate, okay, which we see previously. So this block basically gets the K1, K2 value and returns the error for each profile. Here we have a block that is only for capturing the history of the optimization. It will collect each value produced during the optimization process and make a view for the end user to follow the optimization. And finally, here you have a block that is only for loading the test data, and we see that it uses triangular ports, because the test data, of course, is the same all along the optimization, and that's why we have a non-continuous arrow here. That explains that that block here will receive static test data, and that way we make sure that the test data is exactly the same for each iteration of the optimization process. So I think it's a very clear view of the optimization problem, and very useful to share um, with the end user. Now I would like to switch to a live demo. So um, let me just switch here to my P7 workflow. So here it is. You see it's exactly the same. Let's put myself in the shoes of the end user. So as the end user, I will receive that workflow in read only. I cannot modify it. I have a README here which I can open and see the instruction for running the workflow properly. Okay, I just have to follow the to follow the instructions. So let me let me create a workflow run for configuration. So you see the workflow did not start yet. I still have to do some manipulation. I will load my data flow. So I need to switch to the folder of the run. I will upload my flow data. So as you understand, this can be applied to any problem. I mean, the flow data doesn't have to be static. The end user can use the workflow for different use cases and calibrate different um, Venturi meters for different projects. So it scales basically, and then I just have to check my parameter and parameter values. So for example, here I explain the rules how to read my data. The end user is responsible for that, and he needs to make sure that the connection is correct, and then I can click the run button and start the run. So what will happen is that some files will be written here by the optimization process, and step by step I will see interesting design, hopefully, that will be proposed by the optimization problem. I mean by P7 to address the optimization problem. So it's just started. You can see it live. This block executed. It will execute only once, and here I'm iterating through the optimization loop. I can refresh here. See that some folders have been created. Can check them. Okay, there are already some designs. Let's check this design. Here I have a view of this design to evaluate the fit, how the Venturi meter is able to fit to the measurement data. This is something that was developed by the optimization expert for the end user. I also have the optimization history, which is a file which will be updated during the optimization, and that way I can follow the progress of the optimization, check if there are some interesting results. So for example, I can refresh it and see the next points that are proposed by the optimizer. So here I see point 13 seems interesting. I can go back, refresh, and check out design 14 and open it. Okay, so this is a very convenient, let's say, framework for the end user to follow the optimization and see if there are some interesting designs. Let me go back to the presentation after this live demo and conclude regarding the next steps. We are planning to focus on Studio for now, develop more use cases and more robust workflows. There is a question of version management which we would like to address. And then the next step is also to develop more web apps once some robust workflows are being captured. Our goal is to tend towards CI/CD, so continuous improvement of our application and deployment continuously, our applications. And as I say, the REST API would be great also for connection with the external tools. This is something we will try to see in the future. And that's it.